Alright, so the next step in cellular respiration will be the citric acid cycle, also known as the Krebs cycle. And so this process is a cycle, so it goes in a circle and it's gonna start with the same reactant and then the product's gonna be the same, which is oxaloacetate. And so the cycle starts off with two acetyl COAs. So since there's two of them, it's gonna go through two cycles. But I'm going to go over what happens in a single cycle. So here goes. So you start off with this again, once again, acetyl COA from the previous process, which was pyruvate oxidation. And then it's gonna enter the cycle and combine with oxaloacetate, which looks something like this, but you don't really have to know that. And then this part of the molecule, COA bonded to SH, is gonna detach itself, and then when they combine, it's gonna form citrate, which is basically it's an ionized form of citric acid. And from there's going to be a NAD plus, and it's going to come in and carry an electron, forming NADH and a hydrogen proton. And after that, it's going to release CO2 from its structure, and after that, later on, there's going to be another NADH, which is going to do the same thing, forming NADH. Oh, my bad, I mean another NAD plus forming NADH. And later on, then there's going to be ADP with a phosphate group that's gonna form ATP. And then later on there's also going to be it's going to be an FAD plus, which is basically similar to an NAD plus except in structure. And it's going to form FADH by taking an electron and a hydrogen. FADH2, my bad. And then after that, finally, there's gonna be one more NAD plus that's gonna come in, take an electron and form NADH with a hydrogen proton. And yeah, that's it. And it's a lot more complex than this. The structure changes throughout the cycle, but we don't really have to know that in detail. We just have to know the products of the cycle that is formed. And so the starting material is acetyl CoA and oxaloacetate. And the end product will be, since there's two cycles, you're gonna multiply everything that's formed here by 2. So there will be 2 ATP, and as you can see there's 3 NADH, so there will be 6 NADH in 2 cycles. And then, there's actually 2 CO2 that is formed, and so as a result there will be 4 CO2 in 2 cycles. And finally, there's also 2FADH2. And yeah, so these numbers is what's produced for one glucose molecule. And so after it does all of its arranging and rearranging, it finally ends up as oxaloacetate. So the main component of the citric acid cycle, what makes it a cycle, is the regeneration of oxaloacetate. And yeah, that's basically it. That's the citric acid cycle. And once again, this happens in the mitochondrial matrix as well. And yeah, so from this point we can calculate our net gain of products so far from the beginning, the net gain. So this will include all the products that we've made since glycolysis, pyruvate oxidation, and the citric acid cycle. So we've made 2 ATP here, but we also made 2 in glycolysis. So far we have 4 ATP, and then we actually have a total of 10 NADH, which was formed in the previous cycles. And then we have 2 FADH2. And so yeah, this is our products so far, and later on we're going to make a lot more ATP in the next process, which is oxidative phosphorylation. And yeah, that sums up the citric acid cycle. Hope that helps.